I'm a grad student here at the Media Lab, and I'm a PhD student, and I'm in speech and mobility group, and I'm doing research related to indoor navigation, both creating indoor positioning system and also developing some information guidance to pedestrians. So people can hold their small device, and our localized positioning system can localize where the user is at and try to provide some directional information as like a car navigation system does to the drivers. So there has been a lot of technology developed for indoor positioning, and that requires a lot of infrastructure. Having some small devices embedded around the this inside the buildings, as many of them, so that my device can talk to each of the device and try to figure out where I am, like a GPS. A GPS is looking like it looks very cheap because we don't see satellites. But if you consider the cost of the satellite, then it's a tremendous amount of a dollar has to be put in or money has to put in order to build that kind of system. Not only the money but also the maintenance because you have to feed power to every small devices inside the building. But my device doesn't require any kind of infrastructure because I'm using magnetic field distortion. So Earth's magnetic field is very flat outside the building. So if we have a compass, it will point to magnetic north. But inside the building, because a magnetic field is distorted inside the building because of the building structure that is has some metal part. Uh, because of distortion, if you try to use your compass, it doesn't work inside the building. But this distortion can be used as some kind of signature to a location. So if we can measure that signature, then we know where we are. So Earth's magnetic field is free as you have Earth, but making the custom board is a bit expensive because it's not mass product. But we have to buy each part and make the device that costs about over $100, but it could be much cheaper if Samsung or some phone manufacturers try to build with the bulk like a lot of quantities, then each sensor could cost less than $1, so it will be very cheap. Comparing to like a GPS chips inside the phone, if you run GPS, you will it will take about like a 5 to 6 hours, and then it would go. The battery will be drained, like it will be completely used. But with this sensors, I haven't really seen like a lot of battery energy usage in the phone, so it's very trivial. Right now, we're not doing head tracking, but instead of using like a head-up mount displays or using small LED screens to do augmented reality, we're using handheld projector. So we're actually projecting the information augmented directly on the object that we are interested in. So for instance, like a navigation assistant tool, that if this is our technology is used for navigation, then if you have a destination, then if you project your projector on the floor, then you will see arrows, and if you follow the arrows, then you get to the destination. In a hospital, I don't know where you've been to a hospital. It's very hard to find pathways, and for elderly people, they kind of look around, but there's too many signs. So maybe the guiding light could be very useful tool to take them to the destination. That's one part. Another part, it could be used for like engineers who try to repair some of the infrastructure in the building, because the pipes and cables are not visible. It's hidden inside the wall. So we can use this guiding light as an X-ray. So if we kind of augment on the wall, then we might see pipes or the cables inside the thing that we know where to cut to get access to these pipes and cables. So that could be one another, area that can be used. So, uh, and also for the tourist and also, for the exhibition, like you could use a guiding light to get some more information from the posters or around the buildings. If you project on the door, then you might have some more information about who is in that office or something like that. So the technology for indoor positioning system is still in working progress because no one actually solved or provided like a solution. There's a lot of noise like multipass problems, or the signal can be bounced off to some different places like a GPS. So there are the satellites, and if you have if you're on the desert, you would get like about a meter accuracy, but inside cities, if there's a tall buildings around it, then you get like a 20 to 30 meter error, which is pretty bad. That inside the building, still we will have that kind of problems, and actually having a guiding light requires a meter accuracy, and with the current technology, I think there is no good technology developed to cover that accuracy. Having a startup with this technology might be a good idea. One part is that because the customer doesn't have to buy any more hardwares, right? You just need some reader of reading magnetic field. So that's a chip. Uh, Downside is that someone has to measure the magnetic field inside the building. So the measuring part is requires some time to measure it. Good news is that once you measure it, the magnetic field inside the building doesn't change that much, so it will stay for a long time. So, but the measuring part is the hardest part, and I haven't really developed like an efficient way to measure the whole building. We have outdoor maps that has like all the streets and all that, but we don't have indoor maps because it's very hard to provide. But indoor maps are very useful. From here to student center, we have to go out, inside the building, outside the building, inside the building, and we have to go inside and out and in and out. But Google cannot provide that information because they don't have that information. So in the future, I'm pretty sure that Google will look into the indoor maps and indoor navigation systems as well. So.